Hey guys, Mr. Backerberg here. In this video we're going to look at functions from data. So when we're looking at a set of data, trying to find a function, there's kind of three steps that we're going to go through. Step number one is that we're going to construct a scatter plot of our data. And then number two, based on the shape of the scatter plot that we're getting, that should hopefully sort of match up with the graph of one of our basic functions that we've been working with. And then what we want to do is take one of those basic functions and try to perform some transformations to help us fit those data points. And step number three is a pretty tall task, and it can require a lot of work, but the invention of the calculator and the invention of the computer has made this a lot easier on ourselves. So we have that technology available to us now to make that third step much easier. So we're going to look at some data in here, and we're going to do a little curve fitting using our calculator. So this is actual data. These are actual recorded temperatures from September 9th of 1999, or 9/9/99. And what we've got is a whole list of cities, and we have their recorded low temperature on that day and also their recorded high temperature on that day. And we're going to use our calculator to try to come up with a model, a function for all of this data. So I've got my calculator fired up, and the first thing I need to do is get all of my data entered into my calculator. So I'm going to hit my stat button, and then I'm going to edit my list. So I'm going to hit enter. In list 1, I'm going to enter in all of the low temperatures, and in list 2, I'm going to enter in all of the high temperatures. Now that I've got all of my data entered in, I want to get a scatter plot of my data. So I'm going to hit my y equals button, and I need to turn my plot on. So I'm going to arrow up to the plot, hit enter to turn that on. Now when I hit graph, I'm not going to see any of my data points because I haven't adjusted my window yet. So in order to adjust our window for our data points, we're going to hit zoom, and then we're going to go down to number 9, zoom stat. And that will automatically adjust our window so that all of the data points show up. Now all of our data points don't seem to fit one of our nice graph shapes, but we should notice that they're all going up, and they maybe look sort of like a straight line, or at least some of them look sort of like a straight line. So what we're going to do is something called linear regression to help us find a line of best fit for these data points. Now in my calculator, what I'm going to do to find my linear regression model is I'm going to hit my stat button, and I'm going to arrow over to calc. And on my calculator, the linear regression is option number 4. So I'm going to go down to number 4 here, and I'm going to hit enter. I want it to pull my x values from list 1, and I'm going to pull my y values from list 2. So I'm going to go down to calculate. I'm going to hit enter, and it will spit out an equation for me of the form y equals ax plus b, and it'll give me an a value, which represents the slope of my line, and it'll also give me a b value, which represents my y-intercept. So now what I can do with this information is I can go back to my y equals, and I can type in this equation to see how well it fits my data. So I hit my y equals. My slope, if I round it off, it was about 0.97x, plus my b value was about 23.01. So now if I graph that out, I can see that line showing up along with my data points. And we can see that this model isn't perfect. Not all of our data points fall closely along our line, but a few of them do. So this is about as close as a line of best fit as we can get. But now what I can do with this is I now have a function that will somewhat model my data. So thinking about those temperatures on September 9th of 1999. So in this function, remember x came from our low temperatures, and our y values, based on how we set it up in our calculator, came from our high temperatures. And with this function, we can now use it to make predictions. So let's say in Madison, the low temperature was 46 degrees. And what I want to do is I want to predict what the high temperature would be. So since I've got a low value, I can plug that in for my x, since my x has represented my low values. So I can take 0.97 times my 46 degrees plus 23.01, and I should get approximately a temperature of 67.63 degrees. So we can approximate the temperature in Madison on this day to be between 67 and 68 degrees. And just in case you were wondering, the actual recorded high temperature on that day was 67 degrees. So here I've got listed out some different types of regressions, what their graphs would look like, and some applications that we can use them for. So linear regressions we know give us a nice straight line. Typically we can use those for things like fixed costs, linear growth, simple interest, linear depreciation, and a whole lot of other things. For quadratic regression, we can see that the picture would give us some sort of a parabola shape. So we can think about something like motion during free fall, projectile motion, parabolic reflectors, quadratic growth, things of that sort. We've also got cubic regression, so volume as a function of a linear dimension, cubic growth, and maybe some applications where quadratic regression doesn't work very well. We've also got quartic regression. We've got natural logarithmic regression. Natural logs we see show up a lot with logarithmic growth or decibels or things involving the Richter scale. A few more in here. We've actually got two different kinds of exponential growth. One where our b value, so the number that the x power is on, is bigger than 1, can get used for things like exponential growth and compound interest and different population models. But if that b value is a fraction or a decimal, then our graph, we can see that our graph is going down instead of going up. This would work well for something like exponential decay or temperature loss, things of that sort. We've also got power regression and logistic regression and sinusoidal regression. And again, we can see different applications of those things listed out as well. That's going to be it for this video. Thanks for watching.